Okay. So then I finally finished them all after midnight last night. I posted the answer key. And so you can see, just FYI, in case you don't remember, I don't know if I told you guys, so there were 12 questions. So 12 times 5 is 60. And then I take the amount you got out of 60, I turn to a percentage. So like, for example, if you got 54 out of 60, that's a 90%. So your score would be the 90. But I did 54 out of 60 is just showing you how I calculated. So number 1 and 2, it's basically, I was nice on number 1 and 2. It's just 2 points each part. So you're saying, wait a minute, it's 5 points each question. So you get the 1 point automatically for free. So even if you missed both parts A and B, I would have gave you -4, which means you still got 1 point. I was being nice. Anyway, you can look at the answer key, see how to do all of it. Commonly missed one would be 5 part B. So the question is f of x continuous at x equals 2? The answer is clearly no, because you can see there's a break there. But remember I told you, you don't say no because there's a hole or there's a, then you're supposed to say a calculus reason. So limit as x approaches 2 of f of x does not exist is what I was looking for. If you want more detail, that's even better. Like if you said limit as x approaches 2 from the left side of f of x equals 3, but limit as x approaches 2 from the right side of f of x equals -1, and 3 does not equal -1. But either or. But if you just said the limit as x approaches 2 of f of x does not exist, that I would accept that. The intermediate value theorem problem, be sure the conditions are met for the theorem and also find the value of C. So a lot of you did not find the value of C. You just stopped after you're saying, all right, IVT applies, and then you stopped basically above the red line. So you're supposed to find it. So you set it equal to -50, and then you solve, and then C equals 4 because it has to be between 0 and 5. Let me see what else. So anyway, take a look at the answer key. Couple people for number 8 and 9, you didn't even take the derivative, you just plugged it in. But remember, the slope of the tangent line is you got to plug it into the derivative, not the original function. Now, a couple things. I noticed from your class, there was a lot of grades of all types. There was A's. I mean, a couple of people got 100% even. And there was scores that were really, really low, like 30s and 40%. So it was a big standard deviation. And then, of course, there was, B's and C's and D's as well. So we're going to have more exams, of course, exam 2 and 3, and then final exam, more quizzes. And then, of course, remember, 5% of your grade is basically class participation. So you basically, if you're here regularly with your video on, which is not a given for some of you, then you're going to get an easy participation, 5% of your grade. Now, so for example, let's say you're here at class every day with your video on. Well, then you get like an A on that 5%. So that'll boost up your average. So maybe you have a 77% class average. Now you're going to go up to an 80, and you'll have a B before you know it. So that helps. And how much it helps, well, it depends what your percentage is. If you have a 99%, it's hard to go up much higher. But, and at the same time, I know it's not like some of you, some students ask for extra credit opportunities. I really cannot give you that. I mean, if you cannot, my exams are pretty fair. I mean, I know some of you will disagree, but if you can't pass the exams and quizzes, you really probably should not be going to 150B. You're going to get thrown into the fire, and you wouldn't. I wouldn't be doing you any giving you any help by just passing you by saying, all right, go do this, this, and this, and you can get a passing grade. Now you can go to math 152, I should say. It wouldn't work. All right. Anyway, any questions for me? General questions, a specific question on a test? All right. So the answer key is on Canvas, so you can go ahead and take a look at it. What I would say is focus on making sure you know how to do especially, well, you need to know how to do all of them for the final, but especially for now, definitely questions 10, 11, and 12. You got to know how to take a derivative right now, okay? Like we just covered implicit differentiation. What are we doing? More derivatives. All right, so let's get back here. Any questions from the homework?
Could you do 3.5, number 9?
Number what?
9.
Yeah. On 3.5? Okay.
Yeah.
So on the left side of the equal sign, we got to use the quotient rule there. I'm trying to think, should I multiply both sides by x plus y, but then it's going to be a mess in other ways. Give me 1 second. Don't look what I'm doing here. I'm trying to, don't look at this. I'm just trying to see if I should do one other route first. It's not going to be much nicer. Oh yeah, what do you think? I should multiply both sides by x plus y and then use the product rule, or should I use the quotient rule?
Funny you ask, we just tried this at tutoring and we tried both ways and we did get answers, but just to check, we plugged in points and I guess we did something wrong along the way. But yeah.
All right, let me do product rule. Is probably a little bit easier, huh?
Yeah, this one's the spreading it out seems easier by just like, yeah, doing that. That was much smoother.
All right, yeah, that's it. So I'm gonna get rid of the fraction. X squared equals y squared plus 1 times x plus y. All right, so now let me go ahead and you FOIL this out, right? Did you FOIL this out, or you just use the product rule here on the right?
We foiled it.
Okay, so you got xy squared plus y cubed plus x plus y. All right, so now let's go ahead and take the derivative of both sides. The derivative of the left side is 2x. Here we got to use the product rule for on the xy squared. So first times the derivative of the second, which is 2y times dy over dx, plus second times the derivative of the first, which is 1. All right, so just FYI, the derivative of this whole thing is all of this. So this is first times the derivative of the second plus second times the derivative of the first. All right, from here it should be pretty smooth. Plus the derivative of y to the third is 3y squared times dy over dx. Plus the derivative of x is just 1, plus the derivative of y, which is dy over dx. So the derivative of the y cubed here is this guy. Derivative of x is 1. Is that all right? We good? Okay, now we got the 1, 2, 3 terms that have a dy over dx. So we're going to leave those on the right side. And then the terms that do not have a dy over dx, which are the squiggly lines, we're going to move those to the left, which is basically 2x is already there. And I'll move the y squared. So then we got the dy over dx is on the right. So that's going to be 2x y dy over dx.
And the 1 also, Professor.
Oh, yeah. All right, so now we'll factor out the dy over dx. There's a +1 now. Then divide both sides by what's inside the bracket, and we're done. So is this what you guys had, or you had something different?
No, we had the exact same thing. So I guess something was up with the one we did with the quotient rule.
Oh, you
yeah.
had the same exact thing, right?
Yeah, we had the same exact thing.
Oh, so it didn't match what you had at the quotient.
No, it didn't match what we had. And then like I plugged in points and then something was not right. So I gotta check that.
Well, did you check it with the back of the book?
My book does not have answers at the back. I have like an online version. So
All right, let me tell you, let me look at the back of the book answer, number 9, right? On section 3.5. It's probably going to be in a different form, but I can tell you if it's going to be the same. I can just look at it.
If instead of foiling, you just did a particle, you'd get the same answer, right?
Yeah, it might be in a different form. Number 9 on 3.5. It's 3.5, right?
Yes.
Ooh. Really? Looks different. X times X plus.
Wait, didn't you say the back of the book likes to simplify it to the furthest point? So a lot of them
Yeah,
are
but this is
different answers.
simplified.
That's what I thought too.
I don't really know how the back of the book has 4 terms in the denominator. I don't know. Well, this is right. You know what also, I don't know if it was this book or it was a different book. From one edition to another, they rearranged the problems, but then they forgot to change the answer in the back of the book. So the answer sometimes didn't match on something. Okay. Oh, Mark, you did the quotient rule and you got it same as the back of the book?
Yeah, I did the quotient rule on the left and then on the right. And I got,
Well, the right is pretty easy if you don't, it's just y squared plus 1, right?
yeah, 2y and then dy over dx.
You know what? Let's go ahead and use the quotient rule. So bottom times the derivative of the top minus top times the derivative of the bottom. Derivative of x plus y is 1 plus dy over dx. All over bottom squared. Equals the right side, which is the derivative is 2y times dy over dx. Derivative of 1 is 0. All right. So now we're going to multiply both sides by x plus y squared. So let's distribute the 2x here. So you got 2x squared plus 2xy minus x squared and minus x squared dy over dx equals 2y times x plus y squared times dy over dx. I went ahead and multiplied both sides by x plus y squared. All right, so then we got I'm gonna move the dy over dx's to one side. So I'm basically gonna move this guy to the other side. Factor out the dy over dx. Divide by what's inside the bracket. Now I know that what's inside the bracket there is a mess. But give me 1 second. So let me look in the back of the book. I think we got it. It's probably just, you would have to multiply that out. If you were to multiply this out, you'd get 4 terms, which should match the back of the book, right, Mark?
The bottom would have 4 terms, yeah. Let's,
Yeah, because you have to, let me just do the bottom and with scratch paper. You have 2y times x squared plus 2xy plus y squared plus x squared. It should be 2x squared y plus 2xy squared plus 2y cubed plus x squared. All right. We have a 2x squared y, 4x y squared. Oh yeah, this is a 4. Plus a 2y cubed plus an x squared. Yep, that's the bottom. And the top is just
you can just minus the 1x
yeah.
squared.
You get x squared plus, and then factor out an x. Yeah, okay. Does that make sense?
Does that match the first answer, Professor? If we went the other route by canceling out the denominator?
Let me see here. So you get x squared. Hold on, I'm just let me. So this is x squared, 2x squared minus x squared plus 2xy over 2x squared y plus 4xy squared plus 2y cubed plus x squared. Right? Oh, and then so that's the answer. Does that answer match what I got here? Doesn't look like it, but it should, right?
I was gonna ask why it doesn't do that if you're using the same.
That the first way you did it is the way I went about it. It doesn't look like it matches though. I don't.
Did anyone try to confirm it by like plugging in a random point?
Well, we got this far and we actually did plug in, and I mean, we didn't get it unless we did the plugging in a bit of a hurry because we were running out of time, but I was just wondering, maybe we could try it out.
Yeah, so let's do this. Let's plug in x equals, let's do x equals, now this is not a proof, but at least let's do x equals 2, y equals 3. Do you want to try that? I mean, to really confirm it, you got to do decimals. That way you know it's not luck, but you can try plug in x equals 2. There's already a lot of 2s and 3s there, huh? How about 4 and 5? Nah, or you can do 2 and 3. But I would say if you're going to use a calculator, use x equals 2.1 and y equals 3.6. If it works for those and you get the same exact answer, then I'm pretty good. We're good. But I don't want to spend any more time on this. We got stuff to cover. So just until we confirm it, for the implicit differentiation, just yeah, let's just leave it the way it is. Like, don't multiply it out. I'll check it later myself. I don't want to waste class time. All right, moving on. Let's go to the next section here. Any of you checking it on your calculator? Take a lot of time. By the way, any questions on 3.5 before I move on to the next section? 3.5, remember now that I taught you exponentials, so you should know how to take the derivative of e to the x and any number to the x. Do you want to do a problem from 3.5?
Yes. Could you do I think it was 55. I did an extra one, but I just wanted to do that one to see if I could do it, but I just got a little confused. It's a little bit a harder one, but I just wanted to see if I could do it.
All right, the arc cotangent of t plus the arc cotangent of 1 over t, which I'm going to call it t to the minus 1, if that's okay. So remember, this is not to the negative 1 power. This means the inverse cotangent function, but this means the negative 1 power. So you got to be careful with what context you see the negative 1, right? They kind of like English class. When you see the word R-E-A-D, depending on how you use it in a sentence, it's either pronounced read or read, right? Depending on where it's used. So same thing, kind of analogy here with the negative 1. It's this, and here it's to the negative 1 power, but here it means inverse of cotangent. So let's take the derivative. H prime of t is equal to, so this is section 3.4. What's the derivative of arc cotangent? Well, it's the same as arc tangent with a negative sign, right? Say right? Okay, no participation. Okay, I'm gonna have to mark you guys down for participation here. Minus 1 over 1 plus t to the minus 1 squared, but then times the chain rule. What's the derivative of t to the minus 1? Negative 1 t to the minus 2. So we got negative 1 over 1 plus t squared. This is going to be a double minus here up top. A minus, a minus. So it's going to be plus t to the minus 2 over 1 plus t to the minus 2. Yeah, I'm sure you can do some other stuff, but I'm going to stop. One second, you guys. All right, so ready to move on to the next section?
Yes.
Let's move along to section 3.6. Derivatives of log functions. So, oh yeah, let me turn my camera to the way that some of you have it. Look at this. Lauren, do you see this? This is you. I guess Mexican. And not just you, Lauren, but it's also oh, where is Herday? Is Herday here today?
Yeah, I'm here, Professor.
Oh no, not you don't even have your camera on today.
Yeah, one sec. Let me move my laptop to the front.
So I had a suggestion for you. Try getting a clamp light.
A clamp light?
Yeah, the ones where you clamps onto your desk, it's like if we're reading. That was a
Yeah.
suggestion from someone in my other class.
I'll try looking for that on Amazon.
Oh, what? No, you can get it at a store. Yeah, Amazon. Well, it's up to you, but we would like to see you sometime before the semester ends. All right, moving on. Let's take the derivative of a log function. Suppose you have y equals the natural log of x. So if you remember, if we want to take, remember natural log means log base e. I want to find out what the derivative of that is. I'll show you how the derivative of this, how you can get the derivative of this by implicit differentiation. But first, let's go e to the both sides. So I'm going to raise both sides. We'll go e to the y equals e to the ln of x. If you remember from college algebra, you do one thing to one side, you got to do to the other. So then what's e to the ln of x? E to the ln cancel each other out, so it's just e to the y equal x. Now I'm going to differentiate both sides with respect to x. So derivative of e to the y is itself times the derivative of y, which is dy over dx. The derivative of x is 1.
When you raised it to the power with e, you said you canceled out ln x, right? Or ln, sorry. Oh no, I'm thinking of derivative. Sorry, I was gonna say, doesn't it just stay the same? But I'm thinking of it being the derivative. But never mind.
Okay. So then divide both sides by e to the y. So dy over dx equals 1 over e to the y. But what is y? Well, go back to the original. Y was equal to ln of x, right? That's what up here. Y is equal to ln of x. So dy over dx so dy over dx is equal to 1 over e to the ln of x since ln of x, that's y, which is ln of x. So dy over dx, what's e to the ln of x? E to the ln cancel each other out, so it's 1 over x.
Where's the other ln that you're canceling it out with? When you say you're canceling out ln with another ln.
No, e to the ln cancel out.
Oh, I see.
Because
Okay.
they're inverse operations of each other, right?
Right, correct. That makes more sense.
Like if you had 2 to the log base 2 of something, they would cancel out. Well, e to the ln is base e, so they cancel out. Remember that from algebra?
Yeah, okay, that makes more sense. I thought you were saying you were canceling out with another ln. I was like, I don't think that's right, but
So after all that, if y equals natural log of x, the derivative is 1 over x. Now you've just memorized that now. The derivative of natural log of x is 1 over x. All right. Are we good? Any questions? So if I say y equals natural log of x, you just say y prime is equal to 1 over x. Or if I said f of x equals. So what if I said f of x equals natural log of 4x squared plus 5? How would you take the derivative of that? Well, the derivative would be 1 over 4x squared plus 5. But then you got to use the chain rule times the derivative of what's inside. What's the derivative of 4x squared plus 5? 8x. And then this would simplify to 8x over 4x squared plus 5. Now, if you see a problem like this in the future, you can go directly from here to here. And the way to remember that is when you have y equals natural log of u, where u could be anything, the derivative is u goes on the bottom, its derivative goes right above it, u prime. So in this case, your u is 4x squared plus 5. So that goes on the bottom, its derivative goes and sits right above it. So it's u prime over u. Does that make sense? Any questions? Any comments? From anyone except Daniel and her day. No, I'm just... Let's take the derivative of this. F of x equals the natural log of sine of x. So you would say what you're taking the log of goes on the bottom. Its derivative goes up top. What's the derivative of sine? Cosine. And this actually simplifies nicely. What's cosine over sine?
Tangent.
Cotangent. Sine over cosine is tangent. This is cotangent. So the derivative of natural log of sine of x is cotangent of x. Isn't that nice? So I like to generalize this with my little funny rule. Y equals natural log of anything. Let's call that anything happy face. So if you have y equals natural log of happy face, the derivative is happy face goes on the bottom, and the derivative of happy face goes above it. So the derivative of happy face is happy face with an antenna. Happy face prime. Now that you know how to take the derivative of logs, you also know how to take the derivative of exponentials, and you also know the product rule, power rule, and all that stuff. Now you can do many more different types of problems. So let's see you try to do this one. Y equals x times the natural log of 1 plus e to the x. Maris, are you at Starbucks again? Using the internet?
No, I just have family over and I stayed outside so I wouldn't get in the way.
Last time I was hanging out at a Starbucks, this is pre-COVID. This guy came up to me and wanted to discuss a business opportunity. Oh my God, long story short, it was one of those multi-level marketing pyramid schemes.
Did you do it?
How much money did you lose?
Do it. I remember a lot. I never did it. The only thing I've ever done was this girl invited me. This is years ago. This has got to be over 10 years ago. Invited me to this, was in a hotel presentation of a business opportunity, how you can make money. I'm like, okay. And it was, I think it was Herbalife actually. This would take a good 15 minutes to explain to you what a shit show it was. But basically, people go on there and they start giving their sob story about how I was broke, I was fat, I was this. Then Herbalife came into my life. I started working from home. I started making all this money and I started losing weight by eating their powders and bars and products. And it's such a great thing. And then this guy comes up. And it's basically 45 minutes in a row, an hour, just a different story from each person. This guy comes back up there. He looks like 250-pound NFL linebacker, like ripped. He goes, yeah, these are Herbalife bars that I did. I go, like, please show us the needle marks in your butt because that's not Herbalife. Trust me, I know about weightlifting. So anyway, they never get to the business opportunity, but basically it's a pyramid scheme. The best way you want to learn about pyramid schemes, how much of a scam there is, you guys know who John Oliver is. He has a YouTube video. It's like a 30-minute YouTube video, just pyramid scheme John Oliver. He has AI, he makes it funny. He talks about how it's a scam. And then these companies, it's not a sort of, they're going to other countries now that they try to expand by going to Mexico and to India. They try to just find people that are not doing well, maybe sometimes financially, and try to exploit them. And more people lose money because they get these boxes of products and they fill up their garage and then they can't sell them. They basically have to eat it or throw it away. That's why I would never wear a LA Galaxy jersey, even if I like the LA Galaxy, because it just says Herbalife really big. It's not a legitimate company, in my opinion. Anyway. Do you guys have enough time to do this, or were you just listening to me the whole time?
I think we're good. I mean, I had time to finish, but I don't know if other people were still working.
You weren't listening to my words of wisdom?
What? I heard your words of wisdom. No pyramid
Okay, thank you.
schemes.
Okay.
Yeah.
First times the derivative of the second. So the derivative of the second, natural log of happy face. So your happy face is 1 plus e to the x. What's the derivative of 1 plus e to the x? Well, the derivative of 1 is 0. The derivative of e to the x is e to the x. Plus second times the derivative of the first. What's the derivative of x? 1. And you're pretty much done. You can't do much here. You can say x e to the x over 1 plus e to the x plus natural log of 1 plus e to the x. And that's it. Any questions? Good. Okay. Let's do now. Now. Sometimes let's do this in a different color here. One more
Wait,
here.
Professor.
Yeah.
I'm sorry, can you explain that one more time? Because I just got the first part. I didn't get the second part. So can you explain
You
that?
didn't get this part. Oops.
No, I didn't.
Okay. So I. So we did. This is first times the derivative of the second plus second times the derivative of the first. So the derivative of x is just 1.
I got it now. Thank you so much. I was doing the other thing. Thank you.
So let's do, and then from here to here, I didn't do much. I just multiplied the x and the e to the x to here. And even if you left it like this top line, that's fine. All right, so let's do one more here. Y equals natural log of 1 plus e to the x whole quantity squared. So now this problem, this is not a natural log function. The main function here, it's a power function. It's something in brackets squared. So you see how this is the main function here is a power function. So the derivative would be 2 times what's inside the bracket. So the derivative of u squared is 2 times u, where your u is the natural log. Now, how do you take the derivative of what's inside the bracket? Well, it's a natural log function. How do you take the derivative of a natural log? Well, what you're taking the natural log of goes on the bottom. Its derivative goes up top. Does that make sense? All right. So remember that you got to remember your properties of logs from Algebra 2 or college algebra. So these properties that I'm going to write are good for all the bases, but I'm going to just write it in terms of natural log. So if you have natural log of AB, that's equal to the natural log of A plus the natural log of B. Do you remember that from Algebra 2? I don't know what it's called these days in high school. Do they still call it Algebra 2 or do they say Integrated Math 3 or something? Well, it depends, I guess, what high school you go to, huh? It's called intermediate algebra in college, and then of course college algebra you cover it again. Natural log of A over B is natural log of A minus the natural log of B. So natural log of a product. What is this? Oh. Natural log of a product is sum of the logs. Natural log of a quotient is the difference of the logs. And then, of course, if you have natural log of something to an exponent, let's call it c, that's c times the natural log of a. So you basically, what that's saying is you can bring this exponent down to the ground, so to speak, and write it as a product. Now, you should know these just because, and then there's other properties as well. They help makes your life easier. So sometimes you want to write a log into different forms because maybe it's easier to take a derivative another way. And by the way, this is true for all bases. So like, for example, if I had log base 5 of xy, I can rewrite that as log base 5 of x plus log base 5 of y. It's not just true for natural log. It's true for all the bases. So what this allows me to do is suppose you're given a question and you're asked to take the derivative of y equals the natural log of 2x plus 1 divided by x cubed plus 5x. Now, I'll wait until you guys catch up here. Don't do the problem. I'm just waiting until you catch up writing everything. Hey, we got some people missing today. Who's not here? All right, so now one way to do this problem, by the way, don't write down what I'm about to write down, because I'm going to go a certain direction. Then I'm going to say, never mind, this is not good, and I'm going to erase it. So do not write this down. So if I try to do this problem the same way as I did all the other ones, I say, all right, this is natural log of happy face. So the derivative would be happy face goes on the bottom, which is 2x plus 1 over x cubed plus 5x. And then the derivative of it goes up top. Well, now I got to use the quotient rule. So it's like bottom times the derivative of the top minus top times the derivative of the bottom, all over bottom squared. Then I have a fractions within a fraction. Then I got to simplify this complex fraction, and it becomes a mess, and it becomes a pain. So that's not what I want to do. Okay, you can start writing now. So what I would do is, before I even take the derivative, is rewrite it using properties of logs. Well, if I have a log of a fraction, that's the same as saying log of the top minus the log of the bottom, right? Natural log, that is. I use that second property that's up here. Now I got two easy problems. I can take the derivative of each one individually. So y prime is equal to natural log of 2x plus 1 is 2x plus 1 goes on the bottom. Its derivative 2 goes up top. Minus, let's take the derivative of the second term. Well, x cubed plus 5x goes on the bottom. Its derivative goes up top. What's the derivative of x cubed plus 5x? 3x squared plus 5. Now, your answer might not match the back of the book because they probably got a common denominator and combined like terms to make it one fraction. But you don't need to do that. Are we good so far? All right, now let's talk about logs in other bases. So far, am I going too fast, by the way? So we know the derivative of y equals natural log of x is 1 over x. Now, what about y equals some other log base b of x, where b could be some other number, because natural log, that's base e. Base b could be like any other number, like, 2, 3, 4, 5, whatever. So the derivative would be 1 over x times 1 over natural log of whatever b is, which can be simplified to 1 over x times the natural log of b. And then if you have to use the chain rule, you still put the derivative of what's on the bottom on top. So let's do a problem. Suppose I ask you to take the derivative of y equals log base 3 of x. Here's what you would do. You would say, all right, normally it would be 1 over x, but it's not natural log, it's log base 3. So I'm going to put an ln of 3 on the bottom in the denominator like that. And that's it. Does that make sense? So what if I asked you to take the derivative of y equals log base 5 of x squared plus the sine of x? You guys want to try doing that one? I'm now sitting in a way that a lot of you sit during class like this. My previous class said, oh, it just looks like a giant eraser. All right. So the derivative, here's how I would do the derivative. Just pretend it's a natural log at first. So you would be, all right, x squared plus sine of x goes on the bottom. Its derivative, 2x plus cosine of x goes up top. Now, normally you would be done, but because it's log base 5, you go times ln of 5 in the bottom. And make sure you put parentheses here so that it's times the whole thing. And that's it. How many of you got that as the answer? All right, very good. All right, so we still got more to do. We're going to talk about logarithmic differentiation after the break. So it's 4:08. Come back at 4:18.